Edgerton Project Position Graphs, a 9th grade conceptual physics video. We're looking at a picture from the Edgerton Project. This is a composite image called Pegasus Throw. A stuffed Pegasus toy was thrown from right to left. Video was captured on a high-speed camera at 300 frames per second. And then this composite image was made every 25 frames, making the time between images 0.0833 seconds each. What is happening to the velocity of the toy in the vertical direction during this throw? What is happening to the velocity of the toy in the horizontal direction? Using a tracking program, students tracked the position of the top of the head of the Pegasus and entered it into Excel. X was the horizontal position and Y was the vertical position. The program lets the user set a scale so that the tracking program knows how many centimeters the whole screen is. In the horizontal direction, the graph of position versus time looks like this. The graph is tracking the position of the head. It goes down because the toy starts on the right side of the screen and is traveling to the left. Where does this graph show the fastest and slowest horizontal motion? Where the slope is the steepest, the head is moving horizontally the fastest. During this part, the head has a large horizontal displacement in 0.1 seconds. What do you think is happening at this part, where the graph of the horizontal position versus time is almost flat? As the toy is thrown, it rotates, it spins around. Here, the head is not really moving much relative to the ground. The body is pivoting around the head, swinging around fast, while the head almost stays in place. On average, the motion has a slope of negative 239.9 centimeters per second. This means that the toy is traveling to the left at around negative 290 centimeters per second. While the average horizontal velocity is negative 290 centimeters per second, there are parts when the head of the Pegasus is speeding up, circled in green, and parts where it is slowing down, circled in blue. We can also plot vertical position versus time for the head of the Pegasus. How does the shape of this graph relate to the motion of the toy? First, the toy is thrown upward. The vertical position goes up. Then, as the toy peaks in the air, the vertical position stays at about the same level for an instant. Then the vertical position begins to decrease as the toy falls down. We would expect the toy to get faster and faster as it falls, but the graph does not get steeper. This is because we are tracking the head of the toy, and at this point the body must be rotating around the head and providing the bulk of the vertical motion. Had we tracked the center of the Pegasus, the points would have made a more parabolic curve. Let's think. What is happening to the velocity of the toy in the vertical direction, and what is happening to the velocity of the toy in the horizontal direction? Look at the two graphs to compare them. Then see if you can answer those questions. Pause the video and write out your answers before proceeding. In the vertical direction, the velocity starts positive, going up, and then slows down to a temporary stop as the Pegasus reaches its peak. Then the velocity begins to be negative as the Pegasus slows down, goes down. It should be getting steeper as the toy gets faster, but the graph actually shows that the velocity of the head is getting a bit slower as the body swings around it for the very last part. In the horizontal direction, the motion is nearly constant to the left. However, because we're tracking the motion of the head, the graph shows that the velocity slows down, then speeds up, then slows down again. This would give us a slightly varying negative horizontal velocity. The slope of the horizontal position graph is around negative 290 centimeters per second, so the toy has a nearly constant horizontal velocity of negative 290 centimeters per second. The negative means it's going to the left.